Okay, so here's some review from grade 9 about algebra and polynomials and what we know about them from grade 9. Some definitions to make sure that you understand the words being used in class. So a term is a single number or a single variable or a combination of numbers and variables multiplied together. Some examples could be something like 5. That could be a term. A or X. Those could be terms. We could have 5x or negative 10x squared or 3xy squared, or any combination of numbers and variables multiplied together would be a term. A polynomial is when we have more than one term added together. So many terms, several terms added together. A one-term polynomial we call a monomial. So that's also like just a single term, but we use these words in different scenarios. So you might see something like 15ab or negative x, both monomials. Binomial, we've already seen a lot of those, would be x plus 5, a plus b. What about 6 plus 7? That's not really a binomial because that can be simplified to 13. So normally, there's some gray area maybe, but normally these things we're talking about when it's simplified. So even under that note, if it was x plus 3 plus x, that looks like it has three things, but when it's simplified, you get 2x plus 3, which is a binomial. So, there's sort of some gray area here. But that's what it would look like. One more example, 5x squared minus 3x. X squared and x are not like terms. Can't add them together. That's a binomial. And then a trinomial. We're going to do a lot of these in this unit. 3-term polynomial. Common ones we see, x squared plus 7x plus 12. So I've got an x squared term, an x term, and a constant. Those cannot be added together. Trinomial. A plus b plus c would be another good example of a trinomial or anything else like that. Just coming back up here for a minute, this is called a constant term because it just has a number, and obviously this is a variable term. And then terms that are a mix of the two have a number part, which we call a coefficient. Is the negative 10 there, and then they also have a variable part, which is the x squared part there. Okay, the degree of a monomial is the sum of the exponents of the variables. So it's a little bit tricky whether we're looking at a monomial, a single term, or polynomial, the sum of many terms. Then we have to take a different look at the degree. And the degree is a tricky thing because it's not really going to be all that interesting until you get to grade 12. And that's where degree starts to all of a sudden you understand what it's talking about, why it's a thing. So, again, we're going to start chipping away at it and thinking about it a little bit right now, but it's not going to have a whole lot of context yet. So the degree of this monomial, you look at the variable, it only has one variable, and it's x to the 1, so the degree of this guy equals 1. What about this one? The degree is the sum of the exponents on the variables, so I add the 2 to the 3, and I get 5. Now, I'm not actually changing the expression at all, so I don't add them together and say like x to the 5 or something like that. I'm just stating the degree of that monomial. This one has no variables, and so there's no exponents, obviously, but what's actually happening here is it has a degree of 0. So any variable has a degree of 0. Anything to the 0 is 1. And so in this case, we would say it has a degree of 0. Again, this looks like, in question D here, it looks like there's an exponent, but I can actually evaluate that. It's 25. This only the degree only has to do with exponents on variables. So this again has a degree of 0. Now the degree of a polynomial is different. It's equal to the degree of the term in the polynomial with the highest degree. So although when we were looking at monomials, a single term, we were adding the exponents, we don't add them between terms. So in this case, this is a binomial, it has two terms. This has a degree of 2, this has a degree of 0, so I pick the biggest, and the degree is 2. But it becomes more interesting when I look at something like this. So this one has a degree of 5, this one has a degree of 2, this one has a degree of 4. I do not add them to get 11. That's not how you find the degree of a polynomial. What I do is I take the largest degree between the three terms, which is 5, and that becomes the degree for the entire polynomial. So the degree of the entire polynomial is 5. Okay, so that's a quick little talk about degree. How do I add polynomials? There's not really much to do here. Really, to me, this is just a collecting like terms question. I would just drop the brackets because this is more the kind of thing you're going to see. Okay, and I would just collect like terms. So I've got a 5x squared and a 1x squared. You add those together to get 6x squared. I've got a negative 16x and a 7x, so I add those together and get negative 9x. And then I've got a 10 minus 9, which gives me 1, so plus 1. Okay, and so adding polynomials, this isn't really a thing we do in grade 10. Grade 10, what always ends up happening is you're doing a bunch of stuff with expressions, and then in the end, just like this, you get something where you have to collect like terms. Okay, subtracting polynomials is a little bit different because people do struggle with this, and it's something that comes up. What we're going to do is we're not really going to look at individual terms and think that I'm subtracting terms. What I'm really going to do is I'm going to distribute this negative sign as a negative 1 into the bracket. So the first bracket doesn't change. It's just a squared minus 4a plus 1. And the second bracket is this negative sign is like a negative 1. So it's going to be negative 1 times 3a, which is negative 3a, negative 1 times 7a, which is minus 7a squared, and then negative 1 times negative 5, which is positive 5. Okay, so I've distributed that through, and then again I go ahead and collect like terms. This is just a much more common way of doing it. We don't see situations where you're subtracting polynomials and you line up the terms and you subtract one from the other. It's not really the way that we do. It just doesn't come up in math. So really it's better to distribute it through, understand that that's a negative 1, distribute it through. And then I have to, again, look at like terms. So I've got a squared minus 7a, which is negative 6a squared. I have a negative 4a and a negative 3a. See how I'm lining up like terms with like terms. So a squareds with a squareds, a's with a's, and next I'm going to do constants with constants. So negative 4a minus 3a is negative 7a. This is where your integer math needs to really come into play. And 1 plus 5 is 6. Next, we'll take a look at multiplying monomials. So for this one, if you remember, we're just going to line up like parts with like parts. So I'm going to look at the coefficients first, and I'm going to do all of them together. It's 3 times negative 2 times 4. So that's negative 6 times 4, which is negative 24. That part's easy enough. Now here's the tricky part. When I look at the x's, I see x to the 2 and x to the 3. I don't multiply those exponents. It's x times x squared. Oh, sorry, there is no x in that last one. That's a y. So it's x times x squared, which is x cubed. I add the exponents. This is like x to the 1. So I add the exponents. And then y to the 1 times y to the 1 times y cubed. Again, I add the exponents. 1 plus 1 plus 3 is 5. Some people say why. Might wonder why. In grade 9, this is probably something that you covered. But for example, because what is x times x squared? Well, x squared means x times x times itself twice. So x times x times x, which is just x cubed. So I have 1 here from the exponent 1 and 2 here from the exponent 2. And so I end up adding those exponents. If I was doing something a little bit more interesting, I might have a squared times a cubed times a. So that would be like a times a times a times a times a. There's the a cubed, that's 3 of them, times another a. But there's no difference between multiplying the different a's. So I've got 2 and 3 and another 1, and that gives me a to the 6, which is the same as 2 plus 3 plus the 1 that we don't see there, right? So there's a to the 6. So dividing monomials is the same concept, but instead of adding, we're going to subtract for the exact same reason that we saw. 24 divided by negative 6, so I just divide those. I'm not adding or subtracting there. Those are numbers, those are coefficients, so it's negative 4. So here's a quick example. A times a times a times a, that's a to the 4 on top, and a times a, that's a squared on the bottom, and each of these would divide to 1, and I'm left with 2 a's, so a squared on top, so this works out to a squared. B divided by b is 1, so we don't write it. It's not b to the 1, it's 1, so we don't write it, because anything times 1, it just doesn't change. And c cubed divided by c squared is c. Okay, and here's where we get to distributive property. So this is where I take my monomial out front and multiply it by everything inside that trinomial. And so this is going to be negative 3x cubed, because that's like negative 3 times 1, and then x times x squared. So for all those things that we covered above, it simplifies that way. Negative 3 times negative 6 is plus 18. X times x is x squared. Negative 3 times 2 is minus 6x. And that's done. You cannot add any more. Those are different terms. They're not like terms. X cubed, x squared, and x are all different. Can't add them together. I'm going to multiply the 5 through, and then separately multiply the negative 2x through. I don't continue multiplying the 5. I stop when I get to this bracket. It means 5 times this bracket, so when I get to that bracket, I stop. So that's 5x cubed plus 50x squared plus 5x. Done, that first part. Negative 2x times x cubed is minus 2x, times x squared is 2x cubed, minus 14x squared plus 18x. Now I collect like terms. I've got a couple of x cubed terms, 3x cubed, 5 minus 2. Got a couple of x squared. 50 minus 14 is plus 36x squared, and 5 plus 18 is plus 23x. Again, I can't go any further. Those are all different. They all have different exponents on the x's. Yes, they're all x's, but they're different exponents, so I can't go any further. Okay, one more. You can maybe pause the video and try this one on your own, see if you can get through it. But the 5 goes through those two only. This is a negative. That's something a lot of people have a hard time with. They forget it, and they just subtract m, but I have to multiply it by both. Okay, and then the 3 through there, and then I just have to look for any like terms that might be left in what I have after I multiply. So that's going to be 5m plus 15n. So here we go. This is minus n plus n. And that right there is what so many people would miss. They would leave that as a minus m because they would forget to multiply by both. Plus 3m plus 12. Sometimes people forget that too. They only multiply the 3 by the m and they forget to do it by the 4. That's more in grade 9 though. By grade 10 we're probably on the ball with that. 5 minus 1 plus 3 is 7. I've got an 15n and then one more n, so that's plus 16n. And then 12 is my only constant, so plus 12. It's not so much a matter of right and wrong, but we do usually write these guys in alphabetical order. So I would write m first, then n, and we always try to finish with the constants. Again, it's not a matter of right or wrong. It's not a matter of losing marks on the test, but it's something where if you get used to writing things a certain way, it's easier to see the patterns. And so we try to write it the same way every time.